Okay guys, so let's talk about worksheet 10.4. I'm sorry, 10.5. There seems to be some issues with a couple of the last questions that are asking for calculations. And these are going to require a rice table. And I've started out with a different compound so that you can go ahead and do the two problems that are listed. They are challenging, but I know you can do it. So the first thing that question 81, I believe, gives you is that it has a salicylic acid. You don't care what the acid is. They tell you the 2 Kas, and that's what you need. And then they tell you solubility for it in water. So I'm going to start with solubility here of carbonic acid, which is a different acid, but it'll be okay. And we have a solubility here, and that's milligrams per 1 milliliter. So it's saying that 12.4 milligrams of carbonic acid dissolve in 1 milliliter of water. And I'm just going to cancel out the milligrams because I would multiply by 1,000 and divide by 1,000, so that will cancel out. So it would be that many grams and that many liters. And so now my molar mass for carbonic acid is 62.025 grams for 1 mole. And that would get me to moles per liter, which would be molarity, and that's what I need to start with. So I'm going to take my calculator and I'm going to take 12.8 and divide it by 62.025, and I get as an answer, you can't really see it there, but it's 0.206 molar. So we're at 0.206 molar. So that is my initial concentration of my acid. So under here I've started setting up the problem, and I have my reaction, and now my initial I'm getting from that solubility. So that's going to be 0.206 molar, and I would have 0 of this and 0 of that. My change is that I'm going to lose X here. I would gain X here, and I would gain X here, and you just do it stepwise. And so at equilibrium, this would be 0.206 minus X. This would be X, and this would be X. Here's the Ka for this dissociation, which is 4.2 times 10 to the negative 7th. Since that's to the negative 7th, I'm very confident that I can ignore X here. So I'm going to assume that X is much, much smaller than 0.206. So that means that my Ka, which is Ka1, which is 4.2 times 10 to the negative 7th, is going to equal X times X divided by 0.206. And so I'm just going to go ahead and do the math. So I'm going to take 4.2 raised to the 10 to the negative 7th times 0.206 equals, and so I get now that X squared is going to equal 8.625 times 10 to the negative 8th. And now I'm going to take the square root of that to get to my answer. So second square root, second answer equals, and I get that X equals 2.94 times 10 to the negative 4th. So I was safe in this assumption because this is actually out here 2 more decimal places. And so that is my concentration of hydrogen ions, and it is my concentration of hydrogen carbonate. So now that I have these two answers, they're going to come down here and we're going to do another ice table. So here's my reaction. My initial concentration now, however, will have numbers both here and here. And so this will be 2.94 times 10 to the negative fourth. This will be 2.94 times 10 to the negative fourth. This will be 0. So again, since I have a 0 over here, I know my equilibrium will shift to products. So I'm going to lose x here, I'm going to gain x here, and I'm going to gain x here. And so at equilibrium, this would be 2.94 times 10 to the negative fourth minus x, 2.94 times 10 to the negative fourth plus x, and this would be x. And here's my new Ka. Each reaction, each dissociation has its own dissociation. This is times 10 to the negative 11th. I see it's hard to see there. So maybe if I turn this a little bit, there, that's maybe a little better. So you can see that this number exponent is very, very small. And so I'm going to assume again I can ignore x in both cases. So x is much, much smaller than 2.94 times 10 to the negative fourth. So now my Ka2, which is 4.8 times 10 to the negative 11th, is going to equal x times 2.94 times 10 to the negative fourth divided by 2.94 times 10 to the negative fourth. That becomes a really nice and easy problem, doesn't it? Because now that I've ignored x here and here, this term and this term will cancel out. So now I know that x will equal 4.8 times 10 to the negative 11th. So if we go back and look at the questions in 10.5, it says to calculate the equilibrium concentrations for all the species, what will be the pH of the solution. So now that I know that this is going to equal the concentration of CO3 2-, if I were to add or subtract this to hydrogen carbonate or the hydrogen ion concentration, I won't change that. So I know the concentration of hydrogen ions is going to equal the concentration of hydrogen carbonate ions, which is going to be 2.94 times 10 to the negative fourth. If I wanted to know the pH, we know how to do that calculation. Take the negative log of this number here, and it'll give you the pH. If I wanted to know the concentration of hydrogen carbonate, I would take this original 0.206 and subtract this number. I'm not going to get any change in, subtract this answer. I'm not going to get any change in that. And so I'm going to be able to say that the concentration of H2CO3 is just equal to 0.206. So hopefully that helps you with a question like number 84. 85 is very similar. It does ask you what a KB is, so you know how to calculate KBs. I think everything else should be fine. So let me know if that doesn't help or if that's not enough. Thanks.